Hello friends, welcome to bestreadouts. In this video, we will see how to use sign and run test for testing of population median and randomness of the given sequence or numbers respectively. Before going further studies, subscribe to my channel and press notification bell button to get next updates. Give a thumbs up if you like this video. Question: 20 patients on a certain diet made the following weight gains in pounds. We are given the numbers. Test the hypothesis that the median weight gain is 0 against it is not. Use 5% level of significance. That here we are asked to test hypothesis that the median weight gain is 0. That is, population median is 0. Hence, first step we always write is to test H0 versus H1. Here H0 will be population median equals 0 versus H1 population median is not equal to 0. To test for population median, we use sign test. So first what we'll do, we will write again the given sequence of numbers and we'll go on giving the signs to each number. The way to give the signs are, if the given number is greater than the population median 0, we give positive sign down it, and if the number is less than the median, we give the negative sign. Hence, down 7 we have plus sign, down -6 we have negative sign. Similarly, we are going to give the signs. 3 greater so plus, 1 greater than 0 so plus, 6 plus, 4 plus, 9 plus, -5 is less than 0 so minus sign, 9 plus, -7 minus sign, -3 minus, 7 plus, and so on. Okay. S plus is number of positive signs we have received. Let us count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So we have 13 positive signs and 7 negative signs. S plus is 13. S minus number of negative signs is 7. Now second step we always write in the testing of hypothesis is test statistic under H0. Here test statistic is given by, of course, under H0, capital S equal to minimum over S plus and S minus. That is minimum over 13 and 7. Hence we get the minimum as 7. That is the value for the test statistic S. Now next step is to write the critical region or rejection region. Critical region is given by set of all S such that S is less than S alpha, which equals 5 at 5% LOS. Now let us see how to get this value of S alpha using the table. Here is the table. We can see that for alpha given as 5% and for number of sample points n equal to 20, the corresponding S alpha value is 5. Many tables call this S alpha as small r. So that is okay. Hence we get S alpha as 5. Now fourth step is to write the decision. As we received value of S as 7, which is greater than S alpha, that is 5. We accept H0 at 5% LOS. Again to revise why we are accepting H0, because our critical rejection region tells us that if S is less than S alpha, that is 5, then reject. As S is 7 greater than S alpha, which is 5, we are going to accept H0 at 5% LOS, that is level of significance. So the last step, fifth step that we write in the testing of hypothesis is conclusion. The conclusion is, as we are accepting H0 again to see is population median equals 0 that is median weight gain is 0. We are writing the conclusion as the median weight gain in 20 patients may be 0 pounds. Here remember we have written H0 as population median equal to 0. We could also write population median weight gain equal to 0 versus H1 population median weight gain not equal to 0. Next question. A machine is adjusted to dispense oil in a container. Would you say that the amount of oil dispensed by this machine varies randomly? We are given the data and we are asked to use 5% level of significance, which means alpha is 5%. Here we are asked to test whether the amount of oil dispensed by the machine varies randomly or not. So for randomness, testing of randomness, we use run test. So always first step in writing the testing of hypothesis is to test null hypothesis H0 is the amount of oil dispensed by the machine varies randomly. That is, the given sequence of numbers is random versus the alternative hypothesis H1 is the amount of oil dispensed is not varying randomly. So, in other words, the given sequence of numbers is not random. Now, first let us write down the given numbers, the given sequence. Again, I have copied here. Now, we have to go on giving the signs to these numbers. How to give the signs? We give the plus sign to the number in between two numbers actually if next number is greater than the previous number. For example, 3.6 and 3.9. 3.9 is greater than 3.6, hence we give plus sign. Next number is 4.1. 4.1 is greater than 3.9, so we give plus sign. Next number is 3.6. It is less than 4.1, so we give minus sign. Next number to 3.6 is 3.8, which is greater, so plus sign. Next to 3.8, we have number 3.7, which is less than 3.8. So we give negative sign. And we are going to give the signs like this. Next number smaller, next number bigger. After 4, we have number 3.8, which is smaller. So negative sign, greater positive sign, less negative sign, greater positive sign, negative sign, positive and negative. Now next step is to write the number of runs. The runs of the signs. The run changes when the sign changes from positive to negative or from negative to positive. Now let us see the runs. Here is the first run of positives. So first run. This is second run. Sign changing, third run. Here it is fourth run. Now here fifth run. Sign changing, sixth run. Seventh, eighth, 9, 10, 11 and 12. So in all we have 12 number of runs which we will denote by capital R. Now let us count N1 as the number of plus signs. 1, 2, 3, 4, 5, 6, 7. There are 7 positive signs, hence N1 is 7. N2 is number of negative signs. Let us count them. 1, 2, 3, 4, 5, 6, 7. They are also 7. Okay. Next, second step in testing of hypothesis is to write test statistic under H0. It is given by 12. Third step, as we know now, is critical region, also known as rejection region. It is given by set of all R such that R is less than A or R is greater than B at alpha % LOS. Now our level of significance we are given as 5%. At this level, how to see the values of A and B? Let us see that using the table now. Here is the table for N1 as 7 and N2 also as 7. The cross-sectional value is 3 and 13. Here 3 is the value of small a and 13 is the value of small b. Note that here critical values of small r they are saying, which we denote by capital R, the number of runs. Coming back to the critical region now. Critical region equals set of all r such that r is less than a, which is 3, or r is greater than b, which is 13 at 5% LOS, level of significance. That is, we accept H naught if r lies between a and b, that is 3 and 13. Now next step is to write decision. That is the fourth step in testing. As r lies between a and b, which is 3 and 13, we accept H naught at 5% LOS. So the conclusion is the amount of oil dispensed by machine may be varying randomly. Question. In an industrial production line, items are inspected periodically for defectives. The following is a sequence of defective items capital D and non-defective items N produced by this production line. We are given the sequence of D and N's. We are asked to use run test with level of significance alpha as 5% to determine whether the defectives are occurring at random or not. As seen earlier, to test for randomness, we use sign test. Now, first step again, to test H naught, that is null hypothesis, is the defectives are occurring at random, and H1 is alternative hypothesis, is the defectives are not occurring at random. In other words, the given sequence is random versus H1, the given sequence is not random. Now, here first let us write the sequence again. I have written it here as sequence of D and N's. Now let us go on giving the runs. Run changes when the alphabet changes. So this is first one of D's, second of N's, third of D, fourth run of N, then fifth run of D, sixth run of N, seventh run of D, eighth run of N, ninth run of D, 10th run of N, 11th run of D, 12th run of N, and 13th run of D. So total number of runs that we have is 13. Now let us count N1 as number of Ds, which is 10 in this sequence. N2 number of Ns is 17. Now next step to write is test statistic under H0. It is given by R, the number of runs, which we have already calculated, it is 13. Next step is to write critical region or rejection region. As seen in the earlier sum, the same critical region, set of all R such that R is less than A or R is greater than B at alpha, that is 5% given level of significance. Now let us see how to get the values of small a and small b in this critical region using the table. Here is a table. N1 is 10, N2 is 17. For these two numbers, the intersection gives us values of A and B. A is 8 and B is 19. Let us write these values in the critical region now. Therefore, critical region equals set of all R such that R is less than 8 or R is greater than 19 at 5% level of significance. Fourth step in testing is to write the decision as R, that is 13, lies between A and B, which are 8 and 19. we accept H0 at 5% LOS. And the last step is conclusion. The conclusion is the defectives may be occurring at random. Friends, thank you for watching the channel Best Readouts.